Hey everyone, welcome back to another exciting episode of LeetCode. Today we are tackling a classic and must-know problem, to-sum. This is one of the most common coding interview questions, and if you are preparing for interviews, this one is a must-have in your toolkit. So, what's the problem statement? We are given an array of integers and a target value, and our job is to find two numbers in the array that add up to the target and return their indices. Sounds simple enough, right? For example, if we have the array 250731 and the target is 4, the solution would be 4 and 5 because the numbers at index 4 and 5 sum to 4. Now, we have two important conditions. Each input will have exactly one solution, and we cannot use the same element twice. These constraints make things a little easier because we don't have to worry about multiple correct answers. Before diving into the code, let's think about how we would solve this manually. One way is to randomly pick two numbers, add them, and check if they match the target. Let's try that. Let's pick 5 and 3, their sum is 8, and they don't meet the target. Let's pick 2 and 1, and that gives 3, again they don't meet the target. Now let's pick 3 and 1, that gives us 4. Boom, that's our answer. This works, but it's random and inefficient. Instead, let's move towards a structured approach. Instead of randomly picking numbers, let's check every possible pair in a structured way. We start with the first number and compare it with every number that comes after it. If we don't find a match, we move to the second number and check it against the remaining numbers. We keep repeating this process until we find a pair that adds up to the target. Now, let's quickly code the brute force approach. First, we determine the length of the input array. The outer loop runs through the array but stops at the second to the last element. The inner loop starts at the index right after the current outer loop index and continues until the end. Once we start the outer loop with the first element, we compare it with the rest of the elements using the inner loop. After checking all pairs for the first element, we move to the second element and repeat the process. Once we reach the last element, we have no more elements left to compare it with, which is why the outer loop stops at n-1. If we find a pair that adds up to the target, we return their indices. If no match is found, we return an empty list. Since this brute force approach uses two nested for loops, its worst case time complexity is O of n square, making it inefficient for large data sets. This works, but we can do much better. Now, let's discuss an optimized approach using a hash map. The idea here is that as we iterate through the elements, we compute the difference needed to reach the target and check if we have already encountered that value before. If not, we save the current number and its index in a common place. Let's call this place a hash map or dictionary in Python. For example, if we are at index 1 pointing to number 5, we know that we need -1 to reach the target. Let's go ahead and check if -1 is present in the hash map. As -1 is not found, we update the hash map with 5 and its index. Now, let's repeat the process for the rest of the values and continue to search or update the hash map. The moment we find the required value, we retrieve its index from the hash map and simply return the solution. This allows us to check for a match in constant time O of 1 instead of looping through the array multiple times. Now, let's take a look at the optimized code. We initialize an empty dictionary hash map to store values as keys and their indices as values. We iterate through the list using single loop. For each element, we compute the difference as target minus current number to determine what number we need to reach the target. We check if this difference exists in hash map. If it does, we retrieve the stored index from the hash map and return both indices as the solution. If it does not exist, we store the current number along with its index in hash map and continue the loop. The loop stops as soon as we find a valid pair, ensuring an O of n time complexity. And that's it. We started with brute force, then optimized it using hash maps, bringing down the complexity from O of n square to O of n. If you found this explanation helpful, don't forget to like, share and subscribe. See you in the next one. Happy coding!